Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Optimized ANFIS Method for Detecting Diabetes Patients. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed by using the artificial intelligence in the domain of the healthcare in order to identify the diabetic patients, right? So before moving to this, let's talk about what we will cover into this video. In this video, we will talk about that whatever the application we have designed, in which areas it can be implemented and how it is useful for the society. Then we will talk about what files we need to execute and how we can execute them along with the software requirements for that. Further to that, we will talk about what are the current systems those are working in the same domain, what are the problems identified in them, and how the proposed system is handling the problems. Lastly, we will discuss about the experimental outcomes and the results that are identified after the simulation. So let's talk about the application areas. As the domain that we have implemented is for the diabetic prediction, so it is related to the biomedical applications. So it also represents the role of the AI in the healthcare applications where the medical care can be given after identifying the patient. So the automation in the healthcare systems is the main base of this particular area, where from the various patterns of the stats like blood pressure, ECG, and many other related information can be given to the artificial intelligence, and AI will be capable to detect the particular defect or the disease, so that doctors can take the further procedure in order to wait for the decision given from the reports and all. So timely prediction of the disease can save the lives of the patient. So this domain is related to the healthcare and the biomedical, but it is not restricted to this only. It can be implemented in certain other areas also. So let's talk about the code. So the code that we are going to give you is like this, in which there is a folder name code under which all the files has been placed along with the database file. The whole code is implemented in the MATLAB, so you must have the MATLAB software with you, in which we are using the MATLAB 2019A. You can use 2018, 19 or above, but make sure it should be full version, not the trial one. To run the code, you just need to copy the path from here. Just right click, copy, and go to the MATLAB, and you just need to paste it here. Control V, enter. So you can see all the files those were there in the folder can be seen here. Now this is the main code file that you need to run. In this, we are initially reading the database and then processing the whole thing. In order to run the code, you just need to click on the run button and it will start executing. Now let's talk about what are the current systems. In the current system, basically people are working with the database that we are using here is considered from this link, so you can also get it directly from the location. So you just need to paste it and you can get this. So this is diabetic related data set, so you can directly download it from here. There are different other sources also from where you can get it. As you can see, this is for the specifically Indian diabetic database. It is quite similar to the dataset that we are using. All the information related to it is also given in the detail. So it is having the details like the patient is diabetic or not. So what current systems are doing, basically most of the current systems are working on identifying the diabetic by using the machine learning or the deep learning. Initially they are extracting the features, then sending it to the classifier for get training, or then finally the classification has been done. But the problem that we identified is like the data set that that we generally used in the case of the medical domains. Not every field is important and not having any particular patterns in them, so we should avoid those features, only to use the patterned information, so that the classifier can avoid the raw information to learn the patterns. Secondly, the classifier should be dynamic enough so that it can, if the dataset is gonna vary, it should be easily get trained every time. We need not to experiment the different classifiers. So in the proposed method, what we have done, in the initial phase, initially out of the initial dataset, we are selecting the best features by using the optimization algorithm name GWO, that is gray wolf optimization, which was proposed in 2014. So you can get the details from the online also. Here GWO, gray wolf optimization, so it was proposed in 2014. So if you are going to run this paper, all the details of the algorithm has been given into it. So next to that, in the GWO, the optimization fitness function has been evaluating the three of the factors. Those are standard deviation, average data information, and the correlation among the data. So these important factors are being evaluated by using the fuzzy, normal fuzzy system, in which the fuzzy is being designed in order to calculate these parameters based the weightage of the system. So we have designed the fuzzy system by using the fuzzy. You just need to write the fuzzy in the command window and this window will appear. Then you can go to file, then import, then from file. This is the fuzzy system that we have designed in order to evaluate, where three parameters will be given. On that we have given certain rules in order to give the weightage. So the weightage will be given from 0 to 1. So all the information, you can see that low, medium or high, three categories of weightage will be there. On that behalf, the weights will be assigned and best feature set will be calculated. So you can see initially the database is being read. After reading, we are selecting total of the 4 features, because the data set that we are using having the 8 features. So out of that, after consulting with the doctors, we got that the 8 are the important ones, so we can't skip them. So 4 are being selected. So in every iteration, best of the set of the features is being selected, and with the most information and the patterns in that has been selected as the best feature set. Once the best feature is selected, that is taken as the data. Then we have implemented the neuro fuzzy system. Instead of being using the decision tree or random forest, which are the basic machine learning models, we are using the neuro fuzzy, which is the combination of neural network and the fuzzy logics in itself. So the fuzzy logics that I was talking about earlier was only to select the features on the weight based. Here the fuzzy neurofuzzy is basically learning the patterns, and on that behalf taking the decisions that under which category the data is there. So initially we are forming a normal neurofuzzy, so that we can propose like neurofuzzy is working effectively. Then we have applied an additional algorithm named GOA, grasshopper optimization algorithm. So similar to like GWO, there is a GOA optimization, but the role of both the algorithm is different. GWO is selecting the best feature, GO is tuning the hyperparameters of neurofuzzy, because the ANFIS neurofuzzy that we are using here having certain parameters in them, where the parameters can be adjusted and the better performance of the net classifier can be achieved. So GO is helping in achieving the best hyperparameters, and on that behalf the further classification is being done and evaluated the outcomes. So the predicted outcomes are evaluated in terms of accuracy, F1 score, precision and recall, and compare with the traditional one, where we are comparing it with the existing methods and the proposed GWO selected features and GOA tuned ANFIS. So this is what we have implemented in the proposed method. So in order to run the code, you just need to click on the run button, so that we can check that what we are achieving from the proposed methodology. So let's run the code. As it is running, you can see here the busy command is there. So it will take some time, because there are certain iteration it need to run to select the best feature, and then the training will be there, and GUI will select the best hyper tune of the neurofuzzy. So best network will be extracted out, which will further use for the classification purpose. So let's wait the simulation to get closed. As you can see, it is running. We have given total of the 50 iterations, out of which the 17 iterations has been done. So it is still running. So let the simulation to get completed, so that the best features out of the total dataset can be selected and further fed to the neurofuzzy. Then the normal neurofuzzy and the proposed neurofuzzy has been there, where the hyperparameters of the neurofuzzy has been updated. So it is still running. You can see it is showing us the overall fitness of the selected set of the features. This is the overall fitness. So as the iteration will increase, there will be a state when the fitness gets static, because at certain duration in the optimization algorithm, the best results cannot be changed, and that is the best solution which will be came out after all the simulation. So you can see these are the information that we are getting, and the network got started. The two of the features that we got, this is the convergence curve that we got from the GWO during selection of the best features. So even fourth and fifth iteration we were selected with the best set of the features. Later on, no best set of the features will came out of it. So this is the initial data set out of which the best samples have been extracted and will plot. The colors are representing the different entities, the four of the entities we have selected, so that's why there are a total of 4 colors. Now you can see the iterations for the targeted outcome has been started, in which the GO is tuning the neurofuzzy to get the best classification, right? So you can see it is working. It will take time because every time in every iteration neurofuzzy get trained with the parameters and expected to get the better results. So might be we need to run it again and again in order to get the highest accurate classifier, so that it can be realistically in the real-time scenario, it can be used for the classification purpose for the diabetic. So the domain is not only for the biomedical only. Here we are working with the diabetic. We can work with the many of the other medical data or non-medical data, because the approach is basically proposing the system which can get the data and train itself with the efficient information, rejecting the non-pattern information, and tuning the neurofuzzy in the dynamic mode in order to get the best outcomes. So you can see so far whatever the initial hyperparameters were there, it didn't get changed, and it is still searching for the best outcomes. So you can see till now 10 of the iterations has been done for the GO. This is for the current run. Obviously if we're gonna run it again, might be the results will be different and the outcomes will be there. So it is expected to the better results still in the comparison with the existing method. So the iterations that we have given for this are like 100, so it will take so much time to get tuned because it is a complex task to get the best hyperparameter, because minor variation in the hyperparameters can fluctuate the results and can get the better outcomes. So let's wait for all the iteration to get completed. So till now, let's wait. So you can see we are almost done with the iteration. 99 of the iterations has been done. So let's wait for the further execution on the outcomes and the comparison that we got in the terms of the accuracy. So the accuracy we have achieved is around 100% for the data set that we have chosen for the classification. So here you can see for every of the iteration calculation, the proposed accuracy is around 100% in comparison to nonlinear DWT, EMD, CNN, and STM, because the data set that is taken for the classification depends upon the data. So the auto tuning of the classifier helps us in achieving the best hyperparameters for getting the trained with the current data set, and gives us the 100% accuracy in the terms of the test data set. So if the data set is, the test evaluation is going to change, so it is expected that there will be a bit variation in the accuracy, but obviously it will be better in terms of the factors in the accuracy and the classification rate for the given data. So further modifications are still possible. For that you can contact us directly and can get the information. Thank you, thanks for watching.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.